So good afternoon to one and all. The previous class we have discussed about this Maxwell inductance capacitance bridge. Already we have discussed. Yes. Screen is visible.
Yes, sir.
Yes, sir.
Okay. We have discussed this one and we have derived this derivation we have derived. I told you people to remember this formula. We are going to solve one example on this one. Okay. So if you want, you can note it down or you can take the screenshot. This formula and this formula you should have to know. Okay. So we have discussed advantages, disadvantages also. Directly I will go for the one example we will take. This is the quality factor. We are going to express this, that is called inductive reactance divided by the resistance. We have already derived L1 and R1. By substituting that value, we will get omega C4 R4 here. So you take a problem. This problem, all of you note down. Still some people are joining. 23, 32, 23, 32 it was. Okay. Question number. The R4 equal to 400 ohm, R3 equal to 600 ohm, R3 equal to 600 ohm, and R4 here, where I will take the annotate, just a minute, spotlight I will take. R4 equal to 1000 ohm, R4 equal to 1000 ohm, C4 equal to 0.5 microfarad, and calculate the values of R1, L1, calculate the value of quality factor of the coil if frequency is 1000 Hz. They have given R2 value, R3 value, R4 value, and C4 value. You have to calculate R1, L1, and if frequency equal to 1000 Hz. So first we have to write the given data as it is. You write down given data. You write down as it is here. Given data equal to R2 equal to 400 ohm, R3 equal to 600 ohm, R4 equal to 1000 ohm, C4 equal to 0.5. So we know the formula, that is R1 equal to R2 R3 divided by R4. We know the formula already. We have derived that formula. We substitute that one. R1 equal to R2 R3 divided by R4 and L1 equal to C4 R2 R3. R2 is given value. R2 is given or not? Going to replace this? R2 is given, that is 400. R3 is given, that is 600. Yes. R2, R3, 400 into 600 divided by R4 equal to 1000. We have substituted here in the above formula. Similarly, for the L1, you substitute. C4 is given 0.5 microfarad. That is called 0.5 10 to the power of minus 6. We have to enter here now. Into R2 equal to 400 into 400 into R3 equal to 600. We calculate this value and tell the answers. Substituted the value and just put in your calculator, you will get the answer. Anybody?
240.
2. Just a minute, I have forgotten to add the link. SYA. $433. How much? How much it is?
R1 equal to 240.
Minus. I will get minus here. Directly we have substituted, then how will you get minus? Okay. I'll display that one. R1 equal to 240 is nothing but 6 into 4. That here you 2020 we cancel. Here 10, 40 into 6, 240 ohms we are going to get here. R1 And here 0.5 into 400 into 600, that is 0.12 Henry. We are going to get that one. 0.12 Henry. We are going to get that one. We have calculated, as per the question, we have calculated R1 and L1 value. R1 we got, L1 we got. Now we calculate the Q factor here now. You know the formula Q factor equal to, what is that? Omega C4 R4. Omega equal to 2 phi F. You use 2 phi. F is already given. Phi is available in your calculator, and substitute this into this. What is that one? C4. This is 0.5. R4 equal to 1000. Substitute that one. Otherwise, directly without entering this formula, L1 R1 is calculated. L1 divided by R1 into 2 phi F omega. That one also we can do calculation. Omega equal to Q equal to omega L1 by R1. Omega equal to 2 phi F I have used into L1 by R1. 2 phi into F is nothing but 1000 they have given. And L1 equal to 0.12 we have calculated. Divided by R1, that is 240, and equal to 3.14. Okay, like this the problems will come. You should have to be remember, and you should have the capability to solve that one here. Is it clear? Any doubts?
No, sir.
No doubts. Very good. Then why you people got very less marks in the ISC then? सबको doubt है क्या? Just a minute. 5 minutes. Where it is now? Is it recording or not?
Yes, sir.
Completion. See, this type of problems may come. So for that reason, you have to read the question paper carefully and check the value of R2, whatever the given data and all the things. No need to copy. As it is, you should not copy that one. You have to apply your theory. First, you have to, by reading the question, you have to write the given data. Then you have to put the formula. In that formula, you have to substitute the known value and calculate the unknown value here. Okay, so it completes the Maxwell bridges, both inductance and capacitance bridges. So now we'll go for the Hayes bridge. Actually, it is also similar or advanced form of Whitson bridge only. Advanced form of Maxwell bridge it is now. So here the quality factor, whatever we are going to measure for the Maxwell bridge is the medium quality factors are less than 10 ohm, but for the more than 10 ohm of quality factor, we are going to use this Hayes bridge. We are going to use. See here, it is also same only 4 branches are there. Here also 4 branches are there. One is AB, BC, CD, and DA here now. All 4 branches are there. It is also combination of resistance, inductance, capacitance here. Instead of parallel resistance in the Maxwell series, Maxwell inductance and capacitance bridge, the capacitor is connected in series here. Capacitor is connected in series now here. Is it connected in series here now? So this branch will consider as unknown branch here now. R1 and L1 we have to consider as unknown resistances. Here unknown resistance and unknown inductance. We have to find a formula for this. Okay, and this R3 and R2 are the standard resistance. R4 is also, and these all are the fixed value we are going to use here now. The fixed values we are going to use here now. We have to derive the bridge circuit. At balance condition, we have to consider, we have to calculate the equation, balance equation we have to calculate. Before starting that one, we have to draw the phasor diagram for this. We have to draw the phasor diagram. Here, current flowing through this path under balanced condition, I will consider as I1, I will consider. And current flowing through this side, through a R2 and R4, that one I will consider as I2, I will consider here now. So 2 currents are there. What I will do, I will take 2 references. I will take one reference as, that is I1, I will take, just a minute, not this one. So here, what I will do, I will take I1, I will take as a reference here now. I'll take I1 as reference current. I will take here. So I1 current is flowing through the what? Resistance, inductance, and resistance here. And I2 current flowing through resistance, capacitance, and resistance here. So comparing I1 is related to the inductance and I2 is related to the capacitance. Which current is leading? Which current is lagging? Can anyone tell me? I1 is related to inductance. I2 is related to the capacitance here. Which current lags? Which current leads? Can anyone tell me? A division students, you can also interact. So current flowing through the inductance lags or leads? Is it audible or not?
Lag.
Lag, very good. Then what about current flowing through the capacitors?
Leads.
Very good, very good. So I have taken here I1 reference here, no? So it should lags I2 and I2 should leads I1 here, no? Where I have to draw I2? I2 upper side आ जाएगा and down side आ जाएगा. The I2 will be on upper side or down side. Anyone can you suggest? I2 should lead I1 or I1 should lag I2. दोनों same है statement. Upper side आना चाहिए क्या lower side आना चाहिए वो बोल दो बस. Any one of you? अभी तो एक option. Upper side. Very good. So here upper side it should have to come. What I will do? I will write this one as I2. Where it went? This one I will write as I2 here now. So this I1 because of I1 and I2 because of this supply voltage only. So the supply voltage, whatever in between I1 and I2 is there, I will draw like this. That is E here now. That is total supply voltage. That one is E here now. So I1 lags the voltage E because it is a inductive current. I2 leads the voltage because it is a capacitive voltage. Okay. Two currents and main supply we have drawn here. Now our aim, what we have to do, I will start here now. Just a minute. Okay. So here, one by one, voltage drop across each path, each elements, we will discuss that one. So the I1 current will flow here. I1 current will flow here, no? So voltage drop across this one, the resistance part is there here, no? So I1 R1 is in phase with current I1 here because the resistance is there. So I1 R1 is in phase with I1 current here now. For that reason, what I will do, I will draw I1 R1 here now. I1 R1 I will draw here now. Same diagram I will reflecting here now. I1 R1. Next, same I1 current will flow through the inductance here now. Through the inductance. So I1 omega L1 we are going to call that one. That is the current flowing through the inductance. It should have to lag. It should have to the voltage drop across this one should leads the current I1 by 90 degree. What I will do, I will take into 90 degree up here. This is what it is. I1 omega L1 we are going to call that one. I1 omega L1 here. Same thing here we have written here. See here. I1 R1 we have taken. Next it is taken up here now. Taken up here now. If any doubts, you can ask in between, you can ask me. Okay. So here it is over. Next I3 R3. Same, it is also same here now. I1 R1 is there equal to I3 R3. That is nothing but I1 R3 also you can write this one. I1 R3 you can write here now. So this part we have completed now. Next, which current is flowing through the ADC? That is I2 current is flowing here now. I2 current. Where is the I2 current? Here we have used the I2 current here now. We have used I2 current here now. So current voltage drop across this one is I2 R2. It should be in phase with I2. So I will use this one as I2 R2. I will use here now. I2 R2. That is we have taken, that is here. I2 R4 and R2. Both are equal to I2 R2 also I will write here. I2 R2 I will write here. Next, here very important is there It is capacitor. Voltage drop across the capacitor should lag the current I2 by 90 degree. Here the I2 is there. Should lagging means ये पीछे आना चाहिए. So we have to draw here, that is I2 omega C2. The angle between these two is 90 degree. So here I2 is there. We have to write like this here. So in between this angle is 90 degree here. No. So this is called, what we are going to call, that is I2 omega C4 here. I2 omega C4. So now we have formed the same equation. We have this one, you by a dotted line you join together this one. So it is same diagram we have reflected here. This is the phasor diagram formation. We are going to call that one. We have to form the phasor diagram for the Hayes bridge here. So other things, what we will do, we are going to, so this phasor diagram is over. We have to write the equation for the under balanced condition. We know that one Z1 Z4 equal to
Z2 Z3.
Z2 Z3. Z1 Z4 equal to Z2 Z3 here. No. So Z1 equal to R1 plus J omega L1. Z2 equal to, tell me, forget किए गया अभी, क्लास मिस हो गए बीच में, अभी लास्ट क्लास में we have discussed Z2 equal to
R2.
How you are telling I2? Z1 equal to R1 plus JXL, that is nothing but R1 plus J omega L1 we can write. R1 plus J omega L1 we can write here. No, Z1 that is called. Z2 equal to, is there any imaginary part here?
No.
There is no imaginary part. There is no inductance, no capacitance. Then Z2 equal to
R2.
R2 only. Next Z3 equal to, here also same thing. There is no imaginary part. So Z3 equal to R3 we are going to consider. And here Z4 is the combination of capacitance and resistance here. Now Z4 equal to R4 minus we are going to use for the capacitance minus J omega, sorry, J divide JXC4 we can use, or we can write that is R4 plus also we can write plus R4 plus 1 by J omega C also we can write, because XC4 equal to 1 by omega C4, na? Yes or no? For that reason, this one, any one we can write here. No, R4 minus JXC4, or that is omega C4. I will write here omega C4 here. R4 plus 1 by J omega C4 here. We can write any one formula here. I will show that one. See, same the explanation we have given this, what do you mean by this resistance, that resistance, and how do we have to draw the phasor diagram. We have written in the deep explanation I have written here. If you have not understood, you can go through this. Phasor diagram कैसे form करने का, I have written everything here. We can go through this one. Directly I will go to the equation. See here, Z1, Z4, Z2 diagram दिया तो नहीं है क्या? Diagram not came here now. Just a minute. I was considered this diagram. Where it went? Okay, see here. We know that at balance condition, Z1, Z4 equal to Z2, Z3 here. Z1 equal to R1 plus J omega L1 we have written. Z1 equal to R1 plus J omega L1 we have written. Next, Z2 equal to, this is, there is no imaginary part. So Z2 equal to R2 directly we can write, and Z3 equal to R3 we can write here. Up to here, there is no problem at all. But Z4, which one I have taken the diagram? That is गलत diagram लिए देखो, कोई भी नहीं बोल रहे, चुपचाप बैठ गए आप लोग. Is this diagram is correct? Whatever I have taken, Where it went? Just a minute. While taking the copy of that, has erased. I don't know, it went starting. Explain inductance page. Okay. This diagram I have to take. I remove this one. Paste this one. Rule number 10 is joining now. Already half an hour late. Okay. See here. Z4, it is matters now here. It is combination of capacitor and resistance. Okay. See here. R4 minus JXC4 we can use for the capacitance. Inductance is means plus we can use that one here. No. Otherwise, we can XC4 equal to 1 by omega C4. And we know the formula. I don't know how many of you know the formula, that is J equal to, sorry, 1 by J equal to how much it is? Minus J. We can write like this. There is a formula is there for the complex term here. 1 by J equal to minus J we can write. Yes or no?
Yes, sir.
In the mathematics, it is there already. So instead of using this one directly, R4 plus 1 by J omega so 4 we can use here. No, this 1 by J, if I have used into numerator, that will become minus J. So minus J we have taken here, omega C4 we have kept here. बराबर है क्या अभी? R4 minus J divided by omega 4, or I have mentioned here, no, R4 plus 1 by J omega C4. We can use any one as per your convenient. You can use that one. किसी को कुछ डाउट है क्या इसमें? बोल दो, रिप्लाई फास्ट, शुड नॉट वेट. कोई तो एक रिप्लाई दे दो मेरे को आगे जाने के लिए. You don't know the requesting mode. आप लोग क्या है? I am requesting you, then also you are not replying. Whenever I will shout at you, then only you will reply. Yes. Z1, Z2, Z3, Z4. Is it clear?
Yes, sir.
Okay. Now what you have to do? This Z1 value substitute here. Z2 you substitute here. Z3 you substitute here. And Z4 value substitute here. Substituting Z1, Z2, Z3, Z4 and Z4 value in the above equation, will get R1 plus J omega L1 into Z4 is nothing but this one we have considered R4 minus J omega C4 equal to R2 R3. This one there is no complication at all. R2 R3 directly we have used here now. Here we have to split this one. R1 into R4. You multiply this one. R1 R4 okay. Plus what we have to do? You substitute, sorry, that one J omega L1 into J omega C4. This one, where it went? L1 by C4 we have to. Here J and minus J, that 1 by J is nothing but plus J, na? That is nothing but minus J will get cancelled. L1 by C4 we are going to get. Here L1 is there, here C4 is there. Omega get cancelled here now, because multiplication will do that one, numerator denominator it will get cancelled. Yes or no? Here J omega L1 is there. J omega L1. Here this one minus J is nothing but 1 by J only, na? Or omega C4 here. Omega C4, that is minus omega C4. This J omega get cancelled. L1 by C4 we are using here now. And next J omega L1 into 4. That is J omega L1 into 4. Minus sign as it is minus here now. So that one we will use that one minus into this R1 here. Now J R1 divided by omega C4 equal to R2 R3. From this one we have to separate R1, sorry, real term and imaginary term we have to separate here. See here, this is very important thing. Up to here there is no problem, but from here only it is a problem here. So separating the real term, this is the real term. Okay, this is the real term. There is no J term here, no complex term is there, real term, and this is the real term. Okay, so this one R1 R4 plus L1 by C4 equal to R2 R3 we have written. But this complete term J omega L1 R4 equal to J R1 omega C4. We can write like this. Yes or no? These two are the imaginary term when J omega L1 R4 minus J R1 divided by omega C4 equal to 0. When I will send this one into RHS side, it will become J omega L1 R4 equal to J R1 omega C4. ऐसा हो जाएगा ना? Only in the cover of blue lines you consider that one. Here J is there, here J it will cancel. Okay. Omega is there. When I will send into here, it will become omega square. This R4 I will send into here, it will become R4 square. And that, sorry, C4 and R4 will be kept as it is here. So like that, L1 equal to R1 divided by omega square R4 C4 here. Now, and here from this one, R4 and L1, see here the L1 term is there, here the R1 term is there. Previously, Maxwell inductance में ऐसा term आया था क्या? R1 equation is different, L1 equation is different. Both were independent to each other. Now they are dependent to each other. Here in the R1 equation, real term equation, L1 term is there. In the L1 term, R1 term is there. Yes? Correct hai kya nahi? The previous equation I will show. Just a minute. I'll show the Maxwell inductance circuit. You can check that one. This final equation you can check. See here. This one. Is there any L1 term here? है क्या L1 term इसमें?
No.
Here R1 term is there. Is there any R1 term? R1 है क्या इसमें?
No.
No. Both the equations are independent to each other, but here the dependent equations we got. So we have to derive the equation still. It is not the final equation. Both are dependent to each other here. Now here L1 term is there. Here R1 term is there. So for that reason, what we have to do, just in this place of L1, to substitute this one here. What we will do, here L1 is there. Where I have to set this one. Here L1 is there. In this place of L1, we have to substitute this whole term. I will substitute here now. We'll do solving the above equation. Here R1, R4 is there. I will write R1, R4 as it is. In this place of L1, I will write this one as R1 divided by omega square. Here also C4 is there. Here also C4 is there. C4 into C4. कोई तो बोल दो. C4 into C4.
C4 square.
C4 square and into R4 we have written equal to R2, R3 we have written here. Okay, equal to R2, R3 we have written here. Here R1 term is there. Here R1 term is there. What I will do, I will take R1 term outside here now. R4 plus 1 by omega square C4 square R4 equal to R2, R3. Okay, this one here now. So from taking the LCM of this one, this whole thing, it is going to multiply into R4 here. Yes, 1 plus 1 by 2. How much it is? How you will write that one? 2 into 1 plus 1 divided by 2. ऐसा लिखते हैं ना? Yes or no? Suppose ये 3 consider करो. 3 plus 1 by 2. It is nothing but 2 into 3 plus 1 divided by 2. ऐसे ही लिखते हैं ना? By taking the LCM. Same thing we have written omega square C4 square R4 into this one, you multiplying this one omega square C4 square R4 into R4, that is called R4 square plus 1 divided by this one as it is we have written here, whole divided by omega square C4 square R4 equal to R2 R3. Now you send this whole term, this complete term into RHS side. The numerator will become denominator, denominator will become numerator. Yes or no? 3 by 2 into x equal to, suppose some y is there. What is the formula for x now? X equal to y we will keep as it is here. And this 3 by 2, when I will send into RHS side, what it will become?
2 by.
Like that, by sending this whole equation, this will go to the numerator, this will come to the denominator. So omega square C4 square R4 into R2 R3. We will write omega square C4 square R2 R3 R4 divided by omega square C4 square R4 square. This is the R1 equation we have derived here. Now you check that one. This is the R1 equation. I am saying that one. In this one, any L1 term is there? L1 term hai kya isme? Is there any L1 term here? Yes? No. Now what you do? You substitute this R1 in this equation here. Now you substitute this R1 here in this equation that is called, here you substitute now. The L1 equation you substitute. R1 ka value idhar substitute karo. What you will get? Then L1 equal to R1 ka place I will write omega square C4 square R2 R3 R4 divided by, already this omega square R4 C4 is there. We keep outside that one. 1 plus omega square R C4 square R4 square into again omega square R4 C4 here. Now by deriving this equation by this one here. Here omega will get cancelled, omega square will cancel here. No, cancel ho jayega nahi kya? Next R4 will get cancelled here. No, C4 and C4 square is there, it will get cancelled here. Yes, so C4 term left here. No, C4 R2 R3 divided by this whole term here. No, this will give the L1 equation here. Now we have derived L1 and R1 equation for the Hayes bridge here. This is applicable for the maximum power quality factor, that is more than 10 ohm quality factors, that is applicable here. Now you substitute your Q factor equal to XL divided by R, that is nothing but XL1 divided by R1 is nothing but omega L1 divided by R1. L1 we have already calculated here. Yeah, R1 already we have derived here. No, so we'll get that 1 by omega square C4 R4 will get the equation here. So this completes the Hayes bridge. It is going to complete. We have any confusion in this one? किसी को कुछ confusion है क्या? This place of L1 you substitute this whole equation and separate R1 equation we will identify. Then that identified R1 equation will substitute in the L1 equation. Then separate L1 we are going to get that one. The final equations are, these two are the final equations. We have to remember these two are the final equations here. Any doubts? किसी को doubt है?
No.
Okay. So we'll go for the next topic, that is called, one more bridge is there, that is same like this one only, but a little bit complicated. Instead of series capacitance we have, so some advantages are there. So I told that one, this is advantages, it is applicable for greater than 1 ohm of quality factor here. Now it gives a simple equation for quality factor. Quality factor equation is very simple. See here, 1 divided by omega square C4 R4, that last fourth branch, resistance and capacitance it is going to use. It is value of resistance for determining the Q factor uses. It is going to use very small value it is going to use. And one disadvantage is that it is not suitable for the quality factor less than 10 ohm. Less than 10 ohm quality factor hai to ye suitable nahi hai. This is one disadvantage of the Hayes bridge. See here now. Now we'll go for the Anderson bridge here. Whatever the capacitor connected, either connect किया था हमने, इधर बीच में और एक 0.1 node we have determined here. They have derived one more node that is called E here, and some variable resistance or connecting resistance we have used here in this circuit here. We have used here now. Anderson bridge gives accurate measurement of self-inductance of the circuit. It gives the accurate value of the self-inductance, and it is going to calculated value. It is going to compare with the capacitance of that one. So this bridge is an advanced form of Maxwell inductance bridge capacitance. We have already derived Maxwell inductance capacitance bridge में कैसे था? Inductance and this capacitor parallel capacitance we were using. That one removed here. This path is connected like this here. It is connected like this. Yes. So in Anderson bridge, the unknown inductance, whatever we are going to is compared with the standard fixed capacitance here. The unknown inductance, it is going to compare with fixed capacitance here now, which is connected between two arms of the bridge here now. In between two arms of the bridge, that is C and D, it is connected here like this. So it looks like parallel path to the R4 only, na? Yes or no? parallel path to the R4. Same like Maxwell inductance capacitance bridge. We can check that one. Only one value that is increased is R1. This resistance R we have increased over there. So we'll start to derive this derivation. Actually, it is complicated. I don't know. It will within 15 minutes it will complete or not. Then also we'll do that one here. So here the L1 is the unknown inductance having the resistance R1. It has the resistance R1 here now. So this is the fixed resistance. This R2, R3, R4, these are the known non-inductive resistance values are there. And C4 is the standard capacitors. That is, we are going to use. This is called C4 RC we have used here now. So this is the derivation. I don't know how many of you will understand this one. Visible hai kya derivation ye? Is it visible? Clear hai kya? Yes. Then also I will go for my, I already have solved this one in a paper and I have attached some photos here now. See here, I will ask questions, for not questions, suggestions, you have to give the reply. Yeah? Try to give the reply. I told that one, the balance condition, whenever the voltage drop across this one equal to this one, then the balance condition will occur. Yes or no? Voltage drop across this and this, or voltage drop across this and this here now. And this has two branch, then one more we have to consider like this. So for all conditions, we have to derive the equations. First, what I will do at balanced condition here, the current flowing through the galvanometer is 0. On that condition, here I1 is there. This I1 equal to I3. Same current will flow here. Yes or no?
Yes, sir.
So I1 equal to I3 we can write. I have written equal to I3. And similarly here, I2 equal to some current will flow here, some current will flow here. No, this current flowing through this capacitor is considered as IC, and current flowing through the resistance R4 it is going to consider as I4. Under this balanced condition, here I2 equal to I4 plus IC we can write IC plus I4. One current it is splitting into two parts. Some current will flow here, some current will flow here. Yes. समझ में आएगा? अभी एक current है I2. After some time, it will get some current will flow through the capacitance. Some current will flow through the R4. So this I2 equal to IC plus I4. We can write I2 equal to IC plus I4. That one we have written here. I2 equal to IC plus I4. So from this one, we can write I4 equal to I2 minus IC here. It will help in the later equations. For that reason, we have derived here only now. I'll take the red color now. So two equations we have derived. Now what we will do, voltage drop across this one equal to voltage drop across this one here. Now under balanced condition, this one also will consider as one node here now. Okay, if voltage drop across BC equal to C, then we can say that the bridge is balanced. The bridge is balanced. So for that reason, what is the voltage drop across this one? Which current? I1 R3. We can write I1 R3 here, no? See, this is I1 equal to I3. We can use I1 R3 equal to what is this one? Voltage drop across this one is nothing but IC divided by 1 by j omega c. You can write like this: IC divided by 1 by j omega c. IC into 1 by j omega c. Yes or no? Voltage drop across this, voltage drop across this. From this equation, what we have to do? We have to, this I1 is equal to I3. So in the place of I3, I will write I1 equation and R3 and IC divided by j omega c here. No, so IC equal to I1 R3 into j omega c. I will send this one into LHS side here. So IC equal to I1 j omega c R3 here. No, we can write like this. Yes. This equation we got. I will consider this equation as equation number 1. Up to here, any doubts? Voltage drop across this equal to voltage drop across this one condition we have used here. Any doubts here up to here? किसी को doubt है तो पूछो. We will wait and we will move. If you have any doubts. Yes? Any doubts?
No.
No. Next, other balance equation we have to write here. Other balance equation is nothing but voltage drop across this one equal to voltage drop across from here to here, A to E. The galvanometer detector is connected here. So this whole branch we have to consider now. So voltage drop across this one is nothing but I1 into this, all the things, I1 plus R1 plus this capital R1 plus j omega L1. Just j omega L1 here now. This is nothing but Z1 here now. I1 Z1 equal to I2 into R2 plus this one here now. Which current is flowing here upside? IC is flowing, na? Same current will flow here in the R also. So IC into R here. We can write like this. So this is one condition. Another condition. Another condition. Clear away? This voltage drop across this equal to voltage drop across this one here now. So we can write I1 R1 plus j omega L1 equal to I2 R2 plus ICR. Is it clear? I2 R2 into ICR. Clear hai kya?
Yes, sir.
Next, what we have to do? Similarly, we will consider another condition that is called voltage drop across this one equal to voltage drop across this one, I2 CR. Here. This one, C2D, we have to consider, but here two paths are there. This one equal to this one we have to consider. So for the CED, what we have to write? IC plus R plus 1 by j omega C. This is nothing but how we have to write voltage drop across this one. It is a R, I will write here, R into C. The parallel path of that one is R4 into I4 here. R4 into the current flowing through this one is I4 and current flowing through this one is IC here now. So this is R, this is C here now. So IC into R plus 1 by j omega C. This branch, we can write, this is one branch only we have to consider first. Yes or no? R plus 1 by j omega C into which current is flowing? IC is flowing, equal to I4 R4. We can write like this, equal to I4 R4. Yes or no? आवाज आ रहा है क्या?
Yes, sir.
R4 in the place of R4, what we have to write? Already we have derived in the starting, that is called I2 minus IC here. So R4 place mein I2 minus IC have substituted. This one you consider as equation number 2. This one you consider as equation number 3. We have identified 1, 2, 3 equations here. You can take screenshot of this one. Screenshot लेके open करके रखो. I will ask whenever I will ask the equation number 1 क्या है, equation number 2 क्या है, equation number 3. You have to tell that one. Still it is not yet completed. This one is not yet completed. Derivation is not yet completed. Remember that one. So we have derived 3 equations, that is a 1 and 2 and 3 here at balanced condition. Next, what we have to do? By substituting equation 1 in equation number 2 here. See here IC is there. This here also IC term is there. We can substitute in the place of IC, we can substitute here. Yes or no? Substituting equation number 1 in equation number 2 and same substituting equation number 1, equation number 3 also. Here also IC is there, here also IC is there. So this equation number 1 we have to substitute in equation number 2 and equation number 3. We will get here now substituting equation number 1 and equation number 2 will get this one as it is, this one as it is. In this place of IC, I have substituted I1 plus I1 j omega C R3 into R here. Now what we have to do? You send this one into LHS side. This side you send it now, and you multiply this all the terms here now. It will become I1 R1 plus I1 R1 plus I1 j omega L1 equal to the this one. When I will send into this side, it will become minus I1 j omega C R3 into R equal to I2 R2 here. Okay. Now from this equation here I1 is there, here I1 is there, here I1 is there, here I1 is there. Now you take separate I1, then again you have to write R1 plus j omega L1, this minus j omega C R3 R here equal to I2 R2. This is equation number 4 here. Substituting in equation number 1 in equation number 2 will get equation number 4. Next step क्या है? Substituting equation number 1 in equation number 3. IC इधर substitute करने के बाद equation 4 आया है. Next, this IC I'll substitute into equation number 3. We will get equation number 5 here now. So substituting equation number 1 in equation number 3, we get here IC term was there in this place. I1 j omega c R3 I have substituted. This is as it is, and I2 my R4 as it is, minus IC term. In this term of IC, I will substitute this one and into R4 here. So now here, what you have to do, here I1 j omega c R3 into R1 plus j omega c as it is, you keep down. This complete term, I will take this one, just a minute, I will take the annotate. This complete term, when I will send into LHS side, it will become plus. Yes or no? This term, if I send into LHS side, it plus में हो जाएगा. Yes or no? The minus term, it will become plus. I'm asking to you peoples only. आवाज आ रहा है क्या? Is it audible or not? Hello? Anybody is there?
Yes, sir.
When the minus term I will send into LHS side, it will become plus term. Yes? Yes, sir. No, I am asking. Still you are not replying. Okay. Here also I1 j omega c R3 is there. Here also I1 j omega c R3 is there. When I will send into LHS side, this one I will take common here now. So R plus j omega c, it is plus R4 term will left over there, plus R4 term I am going to give here now, and equal to I2 R4 I am going to leave here. Here equation number 4, I2 R2 is there. Here I2 R4 is there. So we want R4 we have to remove, and R2 we have to get here. Now what we have to do? I want to get in the place of R2 here now. In the place of R2 I have to get. What I have to do to this equation? You tell me. आवाज आ रहा है क्या? Is it audible? Is it audible?
Yes, sir.
So in this place of R4, I want R2. What I have to do to this equation? You tell me. R4 remove करना है, R2 इधर multiply करना है. So by multiplying this equation by R2 by R4, R4 get cancel हो जाएगा इधर. Yes or no?
Yes, sir.
So multiplying R2 by R4 to the above equation, this equation will get whole thing. I am going to multiply here. Here R2 R4 will come, term will come. Here also R2 R4 term will come. Here also R2 R4 term will come. Here R4 get cancelled. I2 R2 हो गए, and the final equation will get I1 equal to I1 R2 R3 divided by R4 plus j omega. This whole term I have multiplied into inside. I have taken here now j omega c R2 R3 R divided by R4 plus j omega c R2 R3. Here R2 I2 R2 here. Now you compare the RHS of equation number 4 and 5. Both are same here. No reply दे दो, time नहीं है. The RHS side of equation number 4 is I2 R2. Equation number 5 is also I2 R2. Yes?
Yes, sir.
So what we have to do? Equating both the equations. Equating both the equations, what I will do? I will remove I2 R2 here now. LHS of both the equations I will equate here now. Here also I1 term is there. Here also I1 term is there. It will get cancelled. I1 get cancelled. Yes. Now after cancelling that one, what I have to do? I have to separate the real term and imaginary term here. Now we'll separate the real term. R1 is real term. Yes. R1 plus R1 is the real term. I have written here now. This is imaginary. This is imaginary here. R2, R3 divided by R4. That is also real term. I have taken these two terms here now. Real term. This is complete imaginary term here. So R1 plus R1 equal to R2, R3 divided by R4 here. See here. This R1 plus R1, where it is connected? First branch. Now we can tell when I will send this R1 into RHS side, it will become minus R1. So the equation for R1 equation equal to R1 equal to R2 R3 divided by R4 minus R1 here. Now this is the final equation of Anderson bridge here. This is the final equation of Anderson bridge for the resistance R1. Is there any L1 term here? L1 कैपेसिटर L1 टर्म है क्या इसमें?
No,
Is there
sir.
any L1 term? No. So it is independent of L1 here now. Now we will consider the imaginary term. This part is imaginary. This complete part is imaginary here now. J omega L1 minus J omega C R3 will take here. We'll write here now equal to. This is also imaginary. This complete term here now. J omega C R2 R3 R divided by R4 J omega C R2 R3. See here. Here j omega is there, here also j omega is there. We can take j omega common here now. Common ले सकते हैं इधर RHS side में. J omega. Here also j omega is there LHS side. So all the j omegas I will get cancelled here now. J omega get cancelled here now. All j omegas. The term left here now. L1 term is left here now. So L1 minus CR3 is there. This minus CR3 when I will send into RHS side, it will become plus CR3R. It will become plus. So other things we will keep as it is here now. So CR2 R3 divided by R, CR2 R3 plus this one I will send into here now. Okay. So what we have to do now here, you observe one thing here now. Here C is there, here C is there, here C is there. Yes. C we have to take common. Here R3 is there, here R3 is there, here also R3 is there. C R3 we can take outside. Yes, CR3 I have taken, divided by R4 also I have taken outside here now. The term left here now, R2 and R2R plus R2 into R4 because we have taken outside. Then when we will send into this side, inside R4 divided by R4 will have to get cancelled. R2 R4 into R2, R4 into R here now. This is the equation for final equation for the L1 here now. You can check now. Is there any R1 equation here? R1 का इक्वेशन है क्या इसमें? R1 term is there? Any R1 term is there from this equation? Is there any R1 term? कुछ भी बोलो सर, कुछ समझ में नहीं आया बोल रहे. R1 term है क्या इसमें? हेलो. In this equation of L1, is there any R1 term?
No, sir.
So here, is there any L1 term?
No, sir.
Then both the equations are independent to each other.
Yes, sir.
So these two are the final equations. You take the screenshot, you practice the derivation. Already in the PPT it is there. You should have to practice these two derivations. This derivation, this one and Hayes bridge. Both the derivations you have to practice, and we will continue in the next class. Continue in the next class. We'll continue. So we'll stop here only. A division students 1, 3, 14. So many students are present. For you people, it is a repetition. Then also you are not giving any interactions. A division students, try to interact that one. Okay. We'll end here the meeting.